Okay, so now we're looking at exponential functions and the natural exponential function specifically, and we're looking at derivatives and integrals of it. So make sure you have your notes printed out. Make sure you review the natural exponential function. You should have seen it in algebra. But anyway, print out your notes. I gave you a few notes about it. Reminded you that it's the inverse of the natural logarithmic function. But anyway, we're going to look at derivatives first. So I gave you, the rules in there that the derivative of e to the x is e to the x, and the derivative of e to the u is e to the u times the derivative of the exponent. But with respect to x, but I also wrote it in words because I'm a big fan of derivatives, the rules in words. And so to take the derivative of a natural exponential function, you're going to copy your problem down exactly, and then you multiply by the derivative of the exponent. So again, A is just a rule that you want to memorize, but how we get it is when you've got to take the derivative of the natural exponential function, you copy your problem down exactly, and then you multiply by the derivative of the exponent. Well, the derivative of x is just 1. So this is, y prime. Y prime is just e to the x. Okay, so you just want to memorize that the derivative of e to the x is e to the x. All right, so if we did b, all right, so again, I want to take the derivative of that, e to the x squared plus 5. Right, you copy your problem down exactly, and then you multiply by the derivative of the exponent. So the derivative of x squared plus 5 is just 2x. Okay. So when I get ready to simplify this, I can multiply that 5 and that 2x. Okay, so I get 10x, and we write that on the front. E to the x squared plus 5 is my derivative. All right, y equals x squared minus e to the x. Now this one is different because it's not just a number in the front, it's another function. It's x squared in the front. So function times function, you got to do that product rule. So we need a 1 and a 2 and a d1 and a d2. So we're going to call 1 x squared, and we're going to call 2 e to the negative x. All right, so d1, the derivative of x squared is 2x. And then d2, the derivative of e to the negative x is, copy your problem down exactly, times the derivative of the exponent, which would be negative 1. So d2 is negative e to the negative x. And y'all remember your product rule from regular Cal 1. It's 1 d2 plus 2 d1. So we fill that in. We've got x squared times negative e to the negative x plus 2 is e to the negative x times d1, which is 2x. So if I simplify that, I get negative x squared e to the negative x plus 2x e to the negative x. Now, this is probably not the answer you would see in those multiple choice quizzes or on your midterm. Factor out what you can. I'm going to factor out a negative x, and that leaves me with x e to the negative x minus 2. Oh, wait, I can take out an e to the x, sorry. Let me factor out a negative x e to the negative x, and that leaves me with an x and a minus 2. And there we go. That's the product rule. Remember that from Cal 1. And here's another product rule because we have e to the 2x times tangent 2x. We have function times function. So let's do that again. So we'll call 1 e to the 2x, and we'll call 2 tangent 2x. All right, so d1 will be, copy your problem down exactly, right, times the derivative of the exponent, so times 2. I'm just going to go ahead and write it in the front. All right, and then d2, all right, tangent 2x, derivative of tangent. If you remember, the derivative of tangent is secant squared of that same angle times the derivative of the angle, so 2. All right, so here we go. Y prime would be 1 d2 plus 2 d1. So we can fill that in. So we've got e to the 2x times 2 secant squared 2x plus tangent 2x times 2e to the 2x. Let's clean this up a little bit. So I've got 2e to the 2x secant squared 2x plus 2e to the 2x tangent 2x. Remember, these angles are locked in at 2x's. You can't multiply anything in there with it. So again, factor out what they have in common. So they have a 2 and an e to the 2x. So we'd be left with secant, there we go, let me write that better, sorry. secant squared 2x plus tangent 2x. And there we go. Next example, all right, natural log. We looked at derivatives of natural log in that last lesson. So remember, to take the derivative of a natural log, you draw me a fraction bar. All right, whatever's behind the ln on the bottom, and then the derivative of the bottom on the top. So the derivative of 1 is just 0. All right, but just take this derivative of e to the 2x, copy it down, multiply it by the derivative of the exponent. Wait, wrong way. Sorry, there is my answer. And then finally, our last derivative one, this is going to be quotient rule. All right, so remember your quotient rule from regular Cal 1, low d high minus high d low over low squared. So let's do that. So we got low. All right, e to the 2x plus 1. That plus 1 is not in the exponent. It's just e to the 2x, and plus 1 is down. All right, so low d high. All right, so the derivative of the top would be copy it down times the derivative of the exponent minus, all right, now high, which is going to be e to the 2x. All right, d low, so derivative of the bottom, derivative of e to the 2x is e to the 2x times 2, and the derivative of 1 is 0, so nothing there, over the low squared. Okay. All right, so we've got to simplify this. So what I need to do is distribute that, okay? And you'll remember, because this sometimes will catch people off guard, when you've got to multiply, like x to the 4 times x to the 5th, you add the exponents, okay? So keep that in mind. When I distribute, all right, and I'm going 2e to the 2x times e to the 2x, I'm adding up, they're both e to the 2x's, so I'm doing e to the 2x plus 2x, so I've got 2e to the 4x, you're adding those exponents, and then 2e to the 2x times 1 is just 2e to the 2x minus, all right, when I multiply here, I've got a 2, and then you've got, again, same base, e to the 2x and e to the 2x, you keep it and you add those exponents, keep that base, so I'll get e to the 2x plus 2x is 4x over the low squared. And then what happens on the top is these two will cancel out, and so my derivative is just 2e to the 2x over e to the 2x plus 1 squared. All right, so there's a good product rule and quotient rule review from Cal 1. And then we move into integrating these. So again, have your notes. You make sure you're filling this in your notes. I gave you the rules. The integral of e to the x is just e to the x. You want to memorize that. Integral of e to the x dx is just equal to the e to the x plus c. And then the integral of e to the u du is just equal to e to the u plus c. Okay, so those are in your notes, and we'll use those rules to get these examples. All right. So we've talked about u substitution and what we let u be, and when we first did it, we said, all right, let u be what's inside the parentheses, and then we said let u be the angle on the trig word, and then in our last lesson we said let u be the denominator, and now we're going to let u be the exponent on e. So when I see these e's, the first thing I try is u substitution, and I let u be the exponent on e. So if I let u be negative x to the 4th, then du is negative 4x cubed dx. You can tell that this is a regular u substitution if however many x's are there, x cubed is however many I have right there in the front, okay? And if it's not, then later on we'll learn integration by parts. We would try that next, but as long as the number of x's, x cubed and x cubed, as long as that matches, it's a straightforward u substitution problem. All right, so here's how you're going to do it. You're going to take this out and call it e to the u. All right, don't call it u, you're calling it e to the u because we let u just be the exponent, okay? And then you need du, but du is negative 4x cubed dx, and that's exactly what I have. So then this part I take out and replace with du. And then this is just the rule that I memorized. Integral of e to the u du equals e to the u plus c. Switch it back to x's, e to the negative x to the 4th plus c. Okay. All right, let's do another one. Okay, so here's a definite integral, all right? But again, whenever I look and I see the e and it doesn't have a plain old x, I'm going to try u substitution when it doesn't have a plain old x as an exponent. I try u substitution, so I'm going to let u be negative 2x, so du would be negative 2 dx. All right, so integral from 0 to 1. All right, I'm knocking this out as e to the u. Hold on, sorry. Okay, as e to the u. All right, now I need du, and du is just negative 2 dx, so no big deal. I can throw in that negative 2, cancel it with the negative 1/2. So bring that negative 1/2 down. All right, and then I've got negative 2 dx as du. Okay. So memorize the rule. Integral e to the u is just e to the u. So bring over that negative 1/2 e to the u. Instead of doing plus c, we've got a definite integral. We're going from 0 to 1. Now, I don't like to, I never end up changing my limits of integration. I always switch it back to x first, and then I evaluate it. But if you want to change your limits of integration, you need to do that before this step. I'm going to go ahead and switch it back to x, and then evaluate it from 0 to 1. But we talked about that when we talked about u substitution, and I showed you both ways to do it. I just like to switch back to x. That's just me. So I'm going to plug in 1 here. All right, so let's think about what happens. I can't do anything with this one, negative 1/2 e to the negative 2. Right? But when I get this one, look at what happens. Negative 2 times 0 is just going to be 0, right? And anything raised to the 0 power is equal to 1. So I end up with negative 1/2 times 1. So I get negative 1/2 e to the negative 2 plus 1/2. I don't have my calculator with me today, so let's just go with that answer. You could plug that in on your calculator if you wanted. All right, integral of x squared e to the x cubed. All right, again, the minute I see the exponent on e is not a plain old x, I'm going to try this u substitution, so I'm going to let u be the exponent. All right, du would be 3x squared. So again, what you're checking for is you need an x squared and you got an x squared. As long as those are the same, this is a straightforward u substitution. If those are different, we would try something else. Okay, and we'll learn, like I said, integration by parts later. We would try that next. All right, so let's do this u substitution. So I'm going to take out this part as e to the u. All right, I have x squared dx, but I need 3x squared dx. So if I throw in the 3, I'm going to cancel it with the 1/3. So bring down your 1/3, and then you can take out that 3x squared dx as du. And then these are really the easiest ones to integrate because e to the u just integrates as e to the u. You just need to remember to switch it back to x. All right. Integral of e to the x times e to the x plus 1 squared dx. All right, this goes back to u substitution, our second lesson maybe in here. All right, we let u be, when you see a parenthesis to a power, let u be the inside. What's inside the parenthesis? All right, well, then du would just be the derivative of e to the x is e to the x, and derivative of 1 is 0. Which, if you look, this is perfect because now this is u squared. All right, so I called u the whole inside of the parenthesis now, so that does go away and become u squared. And then I need du, which is just e to the x dx, which is exactly what I have. So I can replace that with du, and then this is a power rule. Add 1 to it, divide by the new power. So 1/3 u cubed, so I get 1/3 e to the x plus 1 cubed plus c. Okay, so make sure you're paying attention to the difference of when I, do my replacement. Like this one was u squared. I didn't have e to the u because I called u the whole inside. So make sure you're looking at the difference in something like this one where I just called u the exponent. So I have e to the u in here, and this one where I called the whole parenthesis u. And then our last one is integral of e to the 2x cosecant 2x. So it might take you a couple of tries to figure out what works on this one, but trig word, I'm going to try letting u be the angle. So I'm going to let u be e to the 2x. Then du would be exactly what I have, times the derivative of the exponent, so times 2 dx, which is great because I need that e to the 2x, and I've got that e to the 2x. I can throw in that too. I'm not worried about that, but I've got everything else. So now, let's see. Notice you're not just replacing that with u. You've got cosecant, And we just let u be e to the 2x. So don't write just u there. You've got cosecant u, okay? And now you need 2 e to the 2x dx, and you have e to the 2x dx. So if you multiply in that 2, sorry, you're going to cancel it with that 1/2. So that 1/2 will come down, and then e to the 2x dx becomes du. All right, so you are supposed to have this one memorized, cosecant u. That was one in our very last lesson. We talked about memorizing those, and I put stars by them. So make sure you memorize how to integrate cosecant u. It is the natural log of the absolute value of cosecant u minus cotangent u. Okay, make sure you have that one memorized. So this is 1/2 natural log absolute value of cosecant e to the 2x minus cotangent e to the 2x plus c. All right, so make sure you go try your homework.